have a discussion 3, and our topic is the anonymity of the dark web. As an introduction, the software-defined networking paradigm, or SDN, is deeply transforming the telecommunications networks and has been broadly adopted as an enabling technology in initiatives such as the 5G or the Internet of Everything, which technically IoE or IoT, which IoT is the so general standard these days, such as the smart devices, and also IoE, that's the Internet of Everything, which is the all connectivities established between the IoT, it calls the IoE. Although it has been more than 2 decades since its inception, SDN is constantly evolving, and there are an increasing number of requirements from the technology world demanding that SDN networks be more dynamic, flexible, and secure. The use of SDN networks is expected to increase by 19%, which expected for our needs and our using the network these days. And there are several boosters in UNCing this growth, but much of it's undoubtedly driven by cloud service provider or CSP, and still have the ISP, which is internet service provider, because these days everything going to cloud for our usage, our data, which IoT is the base of technically cloud, and now we started talking about the IoE, who have seen in the innovation that SDN in relation to traditional networks represent a solution to build highly scalable, reliable, and optimized data center infrastructures. In contrast to the mentioned advantages, the SDN architecture presents some vulnerabilities. In fact, the Open Network Foundation, or ONF, issued a paper in which the main security challenges faced by SDN architecture are exposed and intern. The organization proposed a set of principles in that area. This ONF manuscript emphasizes the following, such as the SDN security challenge that may be present when there is centralized control. And adversaries can exploit these security gaps by launching different types of attacks. The origin of this attack doesn't necessarily come from an external source, such as a distributed denial of service attack or DDoS, executed by means of the botnet. And there are also attacks that can take advantage of vulnerabilities inherent in the layers architecture. For instance, among the vulnerable points are the communication channel, through which an attacker can access the controller and perform malicious actions, putting network functionality at risk.
Hi, my name is Kwekude Amweni, and I'm going to talk about related literature and contributions. SDN has gained the attention of both the industry, and several reports show that it's one of the interesting technologies in the networking area. And due to its rapid increase, the security mechanism strategies for the CIA that compose the SDN architecture. SDN architecture reviews based on interface and layers, and it has been divided into 3 blocks. We have the north-bound interface and application, the east-west-bound interface and control plan, the south-bound interface and the data plan. Then it uses the STRIDE threat modeling methodology, and the STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So the STRIDE aims is to ensure that application meets the security requirements of the CIA. So as you can see the diagram, We have the SDN controller, which is in the center, controlling all the switches and all the interfaces. Then the SDN architecture hardest network security features. So one, we have dynamic programming and restructuring of network settings, which reduces the risk of DOS attacks. We have automatic quarantine capabilities for specific network points infected by malicious code, machine learning for malware detection, then security and the SDN controller, which is used for auditing, reviewing, monitoring, updating rule-based access policies, encrypting, and it uses TLC or SSH for secure coding. Then we have the TLC to authenticate endpoints for southbound communication. Thank you.
Security in SDN architecture. The high demand for cloud services is causing traditional networks to become less flexible, programmable, and centrally managed for companies that want to expand. The SDN project aims to provide alternative solutions to current limitations of traditional networks. Between 2001 and 2007, the separation of data and control planes are observed through open interfaces. Since 2007, work has been done on an open interface to achieve communication between the data and control planes. The Open Networking Foundation is a non-profit organization that is leading the SDN project and has around 130 members, including Facebook, Google, Microsoft. This is an SDN architecture. The SDN architecture consists of three planes: the data plane, the control plane, and the application plane. The updating and exchanging of information between these planes occur via interfaces. There are three interfaces in SDN architecture: the southbound interface, the northbound interface, and the westbound interface. The southbound interface links the control plane to the data plane. The northbound interface links the control plane to the application plane, and the westbound interface interconnect the distributed controllers. Understanding these planes and interfaces is essential to understanding the functioning and the communication of SDN architecture. SDN provides a centralized view of an entire network through a controller, simplifying the management of network nodes. It enables the maintenance of a large number of applications or network abstractions that can be shared dynamically. SDN can lead to reduce operating costs and capital expenditure, as specialized hardware or software for a single brand is no longer necessary. SDN is currently being used in a deployment of faster services such as 5G networks. In large-scale implementation, it is important to define limits and security policies for sharing information and resources in SDN due to security threats caused by its layered architecture. Northbound interface and application plane. The application plane is crucial for satisfying the SDN environment needs by providing essential programs and abstractions through a controller. The application plane includes a wide range of applications such as firewall, routing policies, protocols, and more provided by third-party developers. Communication between application plane and the control plane occurs via northbound interface, which has no standardization. REST API is currently the most commonly used API, but ONF is working on Open Interface API to include all stakeholders in the development process. Standardization of a northbound interface is necessary to create corresponding and portable applications that work with the different controllers. The ONF's open source API development is a significant step towards standardizing the northbound interface and enabling the development of powerful SDN applications that meet communities' diverse needs.
Due to the variety of SDN apps and the frequency in which the third parties implement them, these systems might provide security risks. For instance, a malicious application could masquerade as a valid application, access the controller, and alter configuration settings, even by adding fictitious rules that entirely alter the network's behavior. But there are several ways to stop this from happening, like Indago, which uses machine learning and security sensitive behavior graphs to protectively detect malicious programs. Similarly, Shield is a framework that mainly analyzes the behavior of applications by employing the control flow graph, and with this solution, it is possible to identify malicious behavior that could lead to modification of internal network parameters. So, having multiple applications coming from third parties can cause interferences between them. So this generates conflicts in network policies. So such interference can come from an attack or lead to another attack. So given these scenarios, there are proposals such as MSAID, which through algorithms used on the same SDN application code is capable of detecting interference. This is also the case of SAIDE, a proposal to detect and eliminate interference by using mathematical models. In the absence of suitable authentication and access control measures that confirm the origin of applications, a northbound interface allows trust relationship threats, like many of which are derived from impersonation, to be carried out against the controller. The lack of efficient prior authentication and access control procedures for SDN applications leaves the network vulnerable to handling unauthorized requests. The load testing, stress tests, and DOS attacks that were launched through the northbound interface led to negative performance of the examined controllers such as POX, RYU, Floodlight, ODL, and ONOS. In order to solve the authorization problems in applications, fine-grained and coarse-grained access controls have been proposed. Coarse-grained access controls are generally used to cover the perimeter vulnerabilities of a standalone system or applications. And coming to fine-grained access controls, these are those controls that offer more application authorization complexity and details, so which are highly helpful in environments that are more dynamic. Generally, the SDN architecture is used in multi-tenant, multiverse, multi-provider, multi-domain environments. Therefore, incorporating coarse-grained or very rigid access control could lead to abuses in the use of permissions or could slow down the network functionality. So, the authors show that the coarse-grained access control mechanisms is not sufficient to control the integrity attacks on the information flow, since it allows an attack called cross-app poisoning, in which an application accesses the controller and tricks the other application to execute the actions.
Hey everyone, it's Tiff. As seen in the table of contributions, a compilation of papers propose solutions for security issues regarding the northbound interface and application plane. For example, the authors of 42 address problems concerning the lack of access control in cross-domain, multi-domain scenarios. In response, they propose solutions including a multi-domain usage control model, which is a modified role-based access control mechanism adapted for dynamic environments, and a cross-domain role mapping method for additional cross-domain access control. This table also categorized each literature contribution into groups including spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Once again using 42 for example, the contribution was tabulated as E after determination of vulnerability by elevation of privilege. Other papers, such as 44, however, were found to contribute to all 6 categories. The authors of 44 provided a solution to more than one problem. For the issues concerning illegal modification of essential database information and the lack of assigning permissions control, they suggest blockchain to be used as the main approach. Stride threat modeling can be applied against a system in 5 high-level steps. These steps include the decomposition of the system into component parts, plotting of a data flow diagram for each of those components, analysis of threats exposed by the data flow diagram, identification of vulnerabilities, and finally, planning of mitigation strategies. Stride is a lightweight and effective approach for cyber-physical systems, which include critical infrastructures and industrial control systems. This type of modeling provides a comprehensive mechanism for the support in the identification of potential threats. It is important to note that each component of Stride is interdependent and only ensures security by addressing all vulnerabilities according to the categories. Therefore, this is an effective method for ensuring security at the component level in the system design process. Thanks everyone. I hope you enjoyed our presentation.